Welcome back. So now that we've brushed up on the mechanics of the if function, let's take a look at a newer and, in my opinion, much improved alternative to if that will make your life a lot easier once your conditional logic starts getting more complicated: the switch function. So there are actually a couple different flavors, so to speak, of the switch function. One that is better suited to straightforward logic that simply tests for equality between two values, and then another that can handle much more complicated scenarios. Naturally, we'll start with the simple version. So here in our dates table, we have a field that specifies the quarter of the year, but it just gives us the number. Now, what I would like to add is a more user and report-friendly label for quarter that, instead of just listing the number, has the letter Q in front of the number. So instead of 1, we would list Q1. Now, I could add a column like this via the if function, but the problem is we would have to nest several ifs inside of each other. The first condition might be if quarter equals 1, return the value Q1. But then the return value of that first if function, if the logical condition was false, that is to say the quarter is not 1, would have to be another if function that would then test to see if the quarter equals 2. Now, nesting if functions even one level deep is messy enough, but to go 3 or more just makes them very difficult to read and manage and edit after the fact. So that's where switch comes in. Switch gives us a really straightforward, easy to understand and easy to interpret alternative for this kind of multi-level logic. So instead of discussing the theory behind the syntax, I'm just going to dive right into creating our derived column so we can see the switch function in action. So I'll start with the name of our new column, which I'll call quarter name, and then a colon, and then the equal sign. And now I'll enter our switch function. And looking at the suggested syntax that Excel provides us, we see that the first argument should be an expression. Now, in our case, this expression is simply going to be a column in our data, but it could also be the output of some calculation between two columns. In our case, though, we're just keying off the value in our quarter column. So let's go ahead and enter our quarter column for that very first argument. So how this simple version of the switch function basically works is that row by row, it compares the value in that expression we provided for the first argument, which is obviously our quarter field, to whatever we provide in that value1 argument. Then, if the value in our first argument equals the value we entered in the second argument, we return whatever we supply in the third argument, which is result1. So our first level of logic is basically to say, if the value in the quarter field is 1, so we'll enter 1 as our second argument, then return the text string Q1. So far, so good. Now, at this point, this may not look all that impressive compared to a conventional if function. But if you think about it, this is the exact point at which, in an if function, you would have to resort to nesting. But in the switch function, there's no nesting required. If I type another comma, we'll see that the next suggested argument is value2. So this is simply another value that I can compare to the expression we provided in the very first argument, which is our quarter column. So I can type 2, and then a comma, and then simply enter what we want to have returned if that quarter value is 2, which will obviously be Q2. And then continuing this pattern, I can type 3, and then Q3, and lastly 4, and then Q4. And then I can close out our function with a closing parenthesis and hit enter. And so now, just to make sure this worked, let me filter for a few different quarters. So I'll filter for the fourth quarter, and it looks like we have all Q4 values. And then maybe I'll filter for our second quarter, and it looks like we have all Q2 values. So again, just think about how much more difficult this would have been with an if function, where we would have had to nest one if function inside of another, whereas here we have this nice, compact, logical, and readable function that accomplishes the same thing. So one thing I want to point out before we move on to the more complex version of switch is that much like the if function, switch has an else clause, which is kind of a catch-all that assigns a value we specify if none of the logical conditions we lined up were met. So because of that, we actually don't even need these last two arguments of our function, 4 and Q4, because if our quarter is not 1, 2, or 3, we can assume by default that it's Q4. So I can actually remove the 4 here altogether, and what that will do is default our return value to Q4 if the value in our original quarter field is not 1, 2, or 3. The function is smart enough to recognize this pattern of pairs of values and results, and when that pattern is disrupted because we only have a single value at the end of the function after our last pair, our 3 and Q3, the function knows that, oh, that's our else return value. But just to put it to the test, let's hit enter. And then let's again filter for Q4. And our function still worked. Okay, so now that we've got Switch 101 covered, let's move over to our products table to take a look at a more involved example that takes full advantage of Switch's capabilities. So in this table, I would like to create a product category field that looks at the values in our product name field and assigns these to various categories. That way I can track my sales of surfing supplies versus riding supplies like bikes and skateboards versus beach supplies like beach chairs or umbrellas. Now technically we could use the exact syntax that we introduced in the last example for this. The format would simply look like our name column would be the very first argument that all of our logical tests look at, and then you just have a series of pairs of values with whatever we want the category for that value to be. For example, we could say if the name is balsa board, then surfing supplies. If longboard, then surfing supplies. If shortboard, then surfing supplies, and so on and so forth. But as you can see, we have 25 records in our products table, so we would be writing out 25 different pairs of values and return results, which kind of defeats the purpose of using the switch function for convenience and readability. Now, fortunately, there is an operator in DAX called the in operator, which lets us compare a single value against a list of other values. So for example, instead of asking, is the value in our name column balsa board, yes or no, we can instead ask, is the value in our name column either balsa board, longboard, shortboard, softboard, bodyboard, etc., all in one operator, instead of having to create a separate pair of arguments in our switch function for each individual value. Now the only caveat here is that by default, the switch function only permits simple tests of equality. That is to say, we can't use more complex logical tests like greater than, less than, or, in this example, the in operator. But fortunately, as we're about to see, there is a workaround, and that is to make the first argument of our switch function the true function, which simply returns the logical value of true. Don't worry too much about why this is the case. Just remember that if you want to use more complex logical conditions than simple equality in your switch functions, the very first argument of your function should be true. What this does is not only allow us to use more complex logical operators, but it also removes the restriction that we can only compare a single value at all the levels of our switch function. So before, we were limited to just using values from a single column, but with this approach, you can perform logical comparisons on as many different fields as you want. So with all that said, let's see how this works in action and create our new product category field. So I'll name it product category. And then of course our colon and equal sign. And then we'll enter our switch function. And now, again for that very first argument, instead of entering a column that we want to perform our logical tests against, we're instead going to enter the true function. And that will require an opening and closing parenthesis. And then for our value and result pairs, instead of our value simply needing to be just that, a value, it can actually be a logical comparison. So we can say name, and then the in operator. And now what we're going to do is test to see if the value in a given row is in a list of names that we specify. So the syntax for the in operator is just slightly funky. Instead of using parentheses after it, you use brackets, these guys right here. So now within those brackets, I simply need to create a list of the things that I want to test whether the name in our given row belongs to. So I'll start by typing balsa board, and then longboard, and then shortboard, and then softboard, and then bodyboard, and lastly, skimboard. I'll spare you any further typing now that you hopefully have the point of how this works. So this entire expression is all still just our second argument of this function. This is basically a logical test. It says if the name in our products table for a given row is one of these, then return some value. And we specify that value in the very next argument. So for my return value, I'll say surfing products. And at this point, I could absolutely continue to write out more comparisons involving this in operator until we finally have accounted for every single name in our products table. But just for the sake of demonstration, I'm just going to include an else clause here that will say all other products, and then close out our parenthesis and hit enter. And now if we look at our products, we see that our first 6 products are all listed as surfing products because those are the ones that we included in our in list, and the rest of our products are all categorized among all other products. So now that you get the idea, I'm going to go ahead and finish writing out our switch statement here, but I'm going to fast forward the video because there is a lot of typing and I'm not an especially fast typist. Now to make room for what is still going to be a pretty long formula, I'm actually going to click this little down arrow to the right of the formula bar here to give myself a little more room to write the formula. So now right before our else argument, after our very first pair of logical condition and then return value if that condition is true, I'll just start writing out more logical conditions and more return values until all of our products in the table have been covered. Okay, so after a lot of typing, I've finished up my switch function here. And if you look down through our product category field, it looks like our categories are being assigned correctly and make sense. Our beach cruiser bicycle is listed under riding supplies. Our various surfboards are listed under surfing products. And then our other more miscellaneous products are listed under beach supplies. Now I do want to note that while this made for a good example of the power of the switch function, in a case like this, where you're trying to assign categories to a list of things, another option might be to simply create a separate lookup table that you could then join into this table. So for example, I could have created a product category table in which I listed these categories and then join that into my products table to achieve the same result. Generally speaking, the decision of whether to handle something like this with a switch statement or a lookup table depends both on your personal preference and also the granularity and complexity of the logic. If you find that your switch functions are getting really, really messy, and you could argue perhaps that this one is, it might be time to refactor that out into a separate lookup table. Okay, so up next we're going to switch gears just a bit by looking at a function that allows us to reference columns in other tables as we're creating our calculated columns. I'll see you then.